Okay, it is time for a tutorial on adding and subtracting fractions. I'm going to keep this brief. A little review never hurt anyone, but still, let's not spend too much time on adding and subtracting fractions. The fun is in the multiplying and dividing, quite honestly. To make sure we're on the same page with vocabulary, a numerator is the number at the top of the fraction, and the denominator is the number at the bottom of the fraction. So as we talk through this presentation or this tutorial, just want to make sure we're clear on some of the basics so we understand each other. Okay, the easy part here, adding and subtracting fractions. At the bottom of this page, you'll notice that it says when you have a common denominator, just add or subtract the numerators and then reduce if possible. We're not going to remind you to reduce. You always simplify or reduce your answers if it's possible. Now, notice in problem 1, the denominators are the same. Problem 2, the denominators are the same. The denominators are the same on all of these problems. And so this is the easy part, where if you can, best case scenario is we give you problems where the denominators are the same and you go, yes, I don't have to do anything but subtract or add. So go through these 4 problems, write down your 4 answers. So pause the video while you're doing that. Come back, we'll talk through them. Make sure that you're okay with adding and subtracting when you have a common denominator. I know, we started off really quick, but let's talk about it. Okay, I have 1 3/5 plus a negative 2/5. So because the signs aren't the same, we subtract, and 3 minus 2 is 1. So we have 1 whole and 1/5 as the part. Okay. Denominators are the same. It's a subtraction problem, so we're going to subtract our fractional parts first. So because the denominators match, we just subtract the numerators. 11 take away 7 is 4. That gives us 4/12, and 3 take away 2 is 1. So we have 1 and 4/12. And as you know, 4/12, that's not in simplest form. So hopefully you noticed and you reduced it to 4/12 down to 1/3. So it was 1 and 1/3. Are you 2 for 2? Come on. 7.5 plus 8.5. Okay, we'll start with our fractional parts. 1/2 plus 1/2 is 2 over 2. And 2 over 2 is 1 whole. Yeah, so half of a pie plus the other half of the pie is you got the whole pie. So that means we have 7 plus 8, and then our fractional part is plus 1. So 7 plus 8 is 15, plus 1 is 16. So don't leave it as 2 over 2. That would be bad. That's bad math grammar. If there's anything called bad math grammar, there's a few things I'll point out to you in this course, and that would be one of them. So 2 over 2 equals 1. 1 plus 15 is 16. All right. The third one here. So again, we start with our fractional parts. I have 3/4 take away 1/4, and 3 take away 1 is 2. So we have 2 over 4. 4 take away 1 is 3. So we have 3 and 2/4. And 2/4 can be reduced. Did you reduce it to 1/2? So it's 3 and 1/2. All right, now if life could just stay with common denominators when you have to add or subtract, things would be so good. But no. Most of the time you're going to have unlike denominators, which is a bummer. So we got to figure out what to do with them. So our sample problem we'll start with is 7 and 5/6 take away 2 and 3/4. Because the denominators don't match, you are not allowed to do anything. You can't subtract at all. The first step is to find a common denominator, the least common denominator. And how you do this is you take both of these denominators and you write out their multiples. So on this row here I have 6, and 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30. And I go, oh, I'm so sick of writing 6s, so I'm going to start with my 4s. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. And I go, stop! Stop! There's a match! When you find a match, you stop. That will be the LCD, which is the least common denominator. That is the lowest number 6 and 4 have in common when you start multiplying. That's how we'll make equivalent fractions. Now, just like in the previous page, we had the problem where this was ended up being the answer of 3 and 2/4. Well, 2/4 is not in simplest form, but we had a common denominator, and that's how we were able to subtract on that problem. So in this case, the least common denominator is 12. So we're going to make equivalent fractions. And to do that, I'm going to just walk you through what I just put up on the screen. We take the mixed number 7 and 5 6, and I need to change that 6 to a 12 because we decided that would be our least common denominator is 12. So I ask myself, 6 times what is 12? Okay, well 6 times 2 is. So if 6 times 2 is 12, I have to do the same thing here to the 5. So I do 5 times 2 is 10. So that's how it becomes 10 twelfths. And if I were to reduce this, I would be going back to 5 6 because I'd be dividing both of them by 2. But we need it with a denominator of 12 because we need a common denominator to add or subtract. So same thing with the mixed number 2 and 3/4. I need the denominator to be 12. So I ask myself, 4 times what is 12? So 4 times what gave me 12? Well, it was 3. So I have to do the same thing to this numerator, whatever this numerator is, and it happens to be 3. So I do 3 times 3 is, and write my answer above that 12, 9 twelfths. Once we have this set up, we are ready to add or subtract. And in this case, we're subtracting. So I just subtract my numerators. 10 take away 9 is 1. So I have 1/12, and 7 take away 2 is 5. So I have 5 and 1/12. And always double check to see if you can reduce. However, just a tip of the day for you, if you ever have a numerator of 1, you're in simplest form. If your numerator is something else, always double check. But 5 and 1/12 is your correct answer. Let's try it again. Oh, this is so nice. They gave us fractions this time instead of mixed numbers. What a blessing. I have 1/8 plus 2/7. It's an addition problem. Everybody likes to add. But we start with the exact same steps. Step 1, you need a common denominator. So we can start writing out the multiples. 8 times 1, 8. 8 times 2, 16. 8 times 3, 24. 8 times 4, 32. And you just keep writing out your multiples of 8. Then you do your 7. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. Aren't you glad you memorized your multiplication tables? And you wrote them all out and you found, oh my gosh, it's way out at 56. Now, if you're wondering, if I write all of this out every time I have to add or subtract fractions with unlike denominators, I'm going to tell you, heck no way. I do this in my brain. I think about the multiples. Why? Because I'm good at my multiplication tables. That's why I have them memorized. Having them memorized makes this easy. I don't have to think about it. I go, okay, 8, 7, what do they have in common? 56. So if you're still struggling with multiplication tables, here's a chance to go, oh, I really should keep working on those. Because otherwise you're doing extra work. Because like I said, these are steps I do in my head. So, but I have to find the least common denominator. I do have to do that. And then step 2 says to write equivalent fractions with this denominator. So let's do it. 1/8, and the 8 needs to have a denominator now of 56. So I ask myself, 8 times what is 56? Well, 8 times 7. So I have to do that here. 1 times 7 is 7. So that's my new equivalent fraction. That's why there's an equal sign. They're equivalent. Now I go to my 2/7. 7 times what is 56? Because I have to have matching denominators. And so we're going to have to multiply by 8. 2 times 8 is 16. Ta-da! Once you have fractions with matching denominators, you're ready for step 3. Add or subtract. Reduce if possible. In this case, we're adding, so I'm going to add my numerators because that's all you do when you add or subtract fractions. You leave the denominator alone once they're matching. 16 plus 7 is 23, and it's 23 over 56. And again, reduce if possible. Now, 23 doesn't have too many things that multiply to make 23. And the only thing is 1 times 23 because it's a prime number. But if I did 23 times 2, that's 46. And 23 times 3 is 66. Which goes right past this. So there's nothing in common. So that is a reduced fraction. All right, now wasn't this fun? No, it's not. But isn't it tolerable? I mean, let's just be honest here. Okay, if that was tolerable, well, let's go to something harder. Sometimes when you subtract with fractions, you have to borrow. Remember in elementary school when you had 20 take away 6 and you're like, well, the 0 can't take away 6, so I have to borrow. And the 0 becomes a 10 and that 2 from the 20 becomes a 1. Well, we're going to have to do something just like this. And I'll show you why. Okay. Step 1's the same. We've had the same step 1 the whole time. If your denominators don't match, you have to find the least common denominator. We have our fractions of 3/4 and 5/6. So we can write all our multiples of 4. 4, 8, 12. What comes after 12? 16, 20, 24, and we keep going. And then we can do our 6s. 6, 12. Oh, wait, stop. I said 12 twice. There we go. We're good. 12 is our least common denominator. Step 2 is exactly the same. What was step 2? We need to write equivalent fractions with our new denominator. Okay, so I have 7 and 3/4. 4 times what is 12? Well, 4 times 3. So 3 times 3 is 9. So I have 9/12. All right, now I take my 2 and 5, 6. 6 times what is 12? Well, times 2. So 5 times 2 is 10. Ta-da! So we have it. So we have our new fractions, 9/12 and 10/12. But here's the problem, because step 3, and the last time we did step 3, told us that we needed to do subtract our fractions. It was time to subtract. But 9 can't take away 10. 9/12 is not bigger than 10/12. But would you agree that 7 and 9/12 is much larger than 2 and 10/12? So yes, this is the larger number, so we can subtract, but we're going to have to strategize. So here's my note. 9/12 can't take away 10/12. You need to borrow 1 from 7. We need to borrow a whole number from 7. When you take 1 away from 7, it becomes 6. So we're going to cross that 7 out. It's going to become a 6. And you need to strategize on how to add 1 whole to 9/12. We're talking about a whole thing. So if this was pie, because I think I really want pie tonight, maybe a chocolate cream pie or coconut cream pie sounds really good. A slice of banana cream. Okay, never mind. All right, so we have 7 whole pies and 9/12 of a pie, because it was a really big pie and we could cut 12 slices, but 9 of them are left. If I can't change the value, I'm just going to strategize. This is going to turn into 6, but I still have 1 whole pie. How many slices would it have? Would it have 1 slice? So it's still 1 whole pie? Can I make it into a different number of slices and it still be a whole pie? I want you to think about that, because here's how we're going to work on this. Okay, I want you to think of the number 1 can be written in lots of different ways. I like calling it an FFO, a fancy form of 1. Doesn't that sound cool? Yeah, in my math today I had to find some FFOs. People are like, oh my gosh, what are you doing? Yeah, fractions, yeah. Anyway, 1 can be written as 3/3. Would you agree that 3 divided by 3 is 1? Or 10 divided by 10 equals 1? Or what about 208 divided by 208? Isn't that equal to 1? And if I want to blow your mind, I could say, what about the square root of 3 divided by the square root of 3? Guess what? It equals 1. We happen to call these, some of us math people, we call them FFOs. These are fancy forms of 1. Each one of these equal 1, but they're fancy because I didn't use that digit 1. Okay? Well, when you have to borrow to subtract fractions, you need to choose the best version of 1 whole to add to your fraction. So 3/3, I could cut the pie, if they were pie, into 3 slices. It would still be 1 whole pie, correct? I could cut it into 10 slices, and as long as no one eats any of them, it's still 1 whole pie. It just happens to have 10 out of 10 slices in it. When we look at the denominator of my partial fraction, my partial pie of 9/12, the denominator is 12. So the best version of 1 I should add is 12/12, because I can add when they have common denominators. I just add my numerators. So if we take that 1 whole pie from 7, so now 7 becomes 6, and I add that 1 whole pie as 12/12, I can add them together because I have a common denominator. And 9/12 plus 12/12, my 1 whole pie, is 21/12. That's how you add 1 whole to a fractional part. Whoa! Okay, so because we couldn't subtract, we needed to borrow 1. So this is what it looks like. I took 7 and I subtracted off 1. There's 6. But I needed to add it over here. So have 6 and 21/12. Now I can subtract the whole numbers in fractional parts. 21 minus 10 is 11. Same denominator, 11/12. 6 take away 2 is 4. I have 4 and 11/12. And always check to see if you can reduce. But 11's prime, And 11 doesn't go evenly to 12, so 11 twelfths. We haven't had to reduce any of them. This is really nice. Okay, so are you acing this now? We should do one more. Let's just do one more. Oh, let's work together. One more. Here we go. Okay, we have 14 and 1 ninths, 5 and 11 fifteenths. We need to subtract. Our denominators are not the same. So step one is still find the least common denominator. So in your head, or writing it out, write the multiples of 9. I have 9, 18, 27, 36, 45, 50, something, 54, 70, 63. Okay, who needs to work on their multiplication today? All right, now do your 15s. Okay, we have 15, 30, 45. 45 is our least common denominator. What was step two? Make equivalent fractions. So let's do it. Okay, 9 times what is 45? 9 times 5. So we have to do that to the numerator. 1 times 5 is 5. This is our equivalent fraction. Let's do it again with 11 fifteenths. 15 times what is 45? 15 times 3. And so we do that same thing to our numerator. 11 times 3 is 33. All right. Now we would like to subtract. We're ready, but 5 can't take away 33. Nope. But we agree 14 and 5 45ths, that's a weird thing to say, is bigger than 5 and 33 45ths. So we are capable of subtracting. I just can't do my fractional parts yet. So I need to find a fancy form of 1. So let's do it. I need to borrow 1 whole from 14. So 14 is going to turn into what number? Say 13. That is correct, 13. And I'm going to add it to the fractional part. Oh, what was our fraction? 45. Oh my gosh. Can you imagine that being a pie? How many parts do you want to cut that into so it's a fancy form of 1? Come on. Are you going to cut into 45 parts? See, I knew you were thinking like me. That's what I did. So I took 45 and added it to 5 because I had 45 over 45. In your mind, you can see 45 written there and 45 written there. It's not really there, but just pretend with me. And 5 plus 45 is 50 over 45 because you keep the same denominator. And that borrowed 1 whole pie from the 14. We cut into 45 parts so that way we could add that whole pie to this fractional part. We don't do anything with the bottom number. Nope, because now we are ready to subtract. 50, take away 33. Yep, 50 can definitely take away 33. And you're going to get, what is it, 17? And 13 take away 5 is 8. Can 17 and 45 be reduced? No, I have another prime number. Bummer. So that's it. Okay. Woo! That was much smoother than the last one. So now I'm going to leave you with your practice problems. We have 4 practice problems here. Look, we get to start with adding and then go subtract, subtract, subtract. So you're going to need to pause the video. I want you to go work on this. It'll probably take you 5 to 10 minutes to do 4 problems. Make sure you do number 4. That's the hard one. If you don't do number 4, I'll be very sad. But make sure you do number 4. Okay, then come back, turn the video back on, and we will talk about your answers. Welcome back to the answer to the practice problems, which was almost going to be a quiz, but for you today it is practice problems. All right, so what did you get for your common denominator for 3 and 8? 24? Nice job. Here we go. 23 over 24 is the correct answer. That's pretty close to 1. If it had been 24 over 24, that would have been a FFO, fancy form of 1. All right. Okay, 2 and 4 fifths. Take away 1 and 2/3. Okay, 5 and 3. Was your common denominator 15? Sweet. And was your final answer 1 and 2/15? Yes. Because this would have become, that would have been times 3. So 12 take away, and that would be times 5, 10. So 12 take away 10 is definitely 2 over 15, can't be reduced. All right, okay, 9 and a half take away 6 and 3/14. Ooh, 2 and 14. Did you use a common denominator of 14? Because you wouldn't even have to change this fraction if you did. Because 2 goes into 14. So 2 times 7 gives you 14, and 1 times 7 is 7, so 7 over 14. And 7 take away 3 is 4. Uh-oh, I think you had to reduce when you're done. So you had 3 and 4 over 14, and you would have had to reduce to 3 and 2/7. Okay. All right, and for your final problem, we have a denominator of 5 and a denominator of 8. Did you get a denominator of 40? Okay, so you're off to a good start. That means this would have been the fraction 8/40ths, and this would have been the fraction 35 over 40. Ooh, 8 cannot take away 35, so you had to borrow. So then 19 became an 18. And because our denominator is 40, how many slices of pie did you make your fancy form of 1 into, your FFO? Okay, 40 out of 40, you got this. So you have 48 take away 35, which equals 13 over 40. So it's 11 and 13/40ths. Is that right? Yeah, 18 take away 7. I think it's right. If you found any errors in this video, please email Sister Jensen at jensenh@BYU Idaho. Yeah, if I made a mistake, please argue with me. But if you need any other help, you can also email me and I'd be happy to assist you in adding and subtracting fractions today and in the future. Have a great rest of your day.